Hello, everybody, and really happy to see you here. Here is our summary, our sum up of the hackathon we have last weekend is Transforming AI Hackathon, Transformers AI Hackathon. And I really thank you for all of us for joining us, for being with us all these weekends. We had more than 1,000 participants. There was working with Transformers, with transforming technologies like GPT-3 and Cohere on your solution. And we have over 51 team. And so we have like 51 team who was working on their project. So there was like really impressive hackathon, and over this hackathon we had a lot of submissions, and we had impressive time to evaluate all of them. And today we are ready to present you our top 3 teams that was chosen by our team and by judges. And yeah, today you will see their presentation, and our founder, which is Matthias Asberg, will choose the first place who will won the credits from DigitalOcean. Yeah, I'm here. My name is Olesia. I'm from marketing team of LabLab.ai. We are the community of builders, of creators who are really passionate about AI as a technology, want to show it to the world, want to build with the technology. And we are like platform to collaborate that allows people to collaborate between each other and to create beautiful projects and beautiful solutions with AI. Kuba, tell me, if I'm not mistaken, Matthias should be on this call right now, right? Great. Matthias, I want to ask you tell a little bit more about LabLab.ai as a platform. Can you please help me with it?
Yes, definitely. Yes, we just want to create a place basically where people come and build around the same technologies that we are deeply interested in. We believe that there is a fundamental platform shift happening in technology, and we see currently see a lot of progression in Transformers. But yeah, we basically created LabLab because we wanted to see, like, can we make AI a bit more fun, innovative, and collaborative, so to say. So that's how it started. Now it's grown very fast over the last 3 months, basically. So now it's over 10,000 people, which makes us super happy and super thrilled. And yeah, that is our only purpose. Behind LabLab is an organization called New Native. And basically what we are doing there is that we are building investment pipeline for AI native companies. We believe there is as we have a fundamental change in platform and also the way we operate and write software, we also believe that this new generation of companies need different types of support, and also that they are capable to move a lot faster through their life cycles. Yeah, so that is shortly about LabLab and New Native. Feel free to visit any of our sites to learn more or reach out.
Thank you, Matthias. Thank you for telling us more about this, the LabLab and New Native, the company that are organizer of these hackathons. And for now, before announcing the top 3 teams and inviting them to present their project to be evaluated by Matthias, I want to just remind you that, guys, you can write your question to the team into the chat, and I will read it, and teams will be able to answer for this question. So it will help us to better understand their project, their idea, and actually the value they are able to create with AI. Yeah, and the first team for now will be Rackle AI. It's the solution that will help recruiters, that will help in talent management, for HR's managers around the world, and we had amazing interview with this team during the hackathon, and this solution is really amazing. So will be super happy to hear about this project. Yeah. So are the team is ready? I did not see. Great. Hello. Just tell to hear us.
Can you hear me?
Yeah, we can.
Perfect.
Great.
I don't know if you can see me right now.
Unfortunately, no, we don't see your screen. Just tell us when you will be ready to share.
Okay. Perfect. Yeah.
Great.
Yeah. Now you can see me now.
Yes, we can see you, but still we do not see your screen.
Perfect. I'm sharing the screen right now.
Great. Cool. I see your screen, so stage is yours. You have 5 minutes to present, and I wish you success.
Thank you. Well, this project is name is Recruit AI, and it's an artificial intelligence tool for recruitment teams. My name is Antonio Ortiz. I will be presenting this project for you. So, real quick, my name is Antonio Ortiz. I am a Venezuela system engineer, and I have been working as a software developer since 2011. And I want to talk about 4 points in this presentation. What is the recruitment process? What the project is aiming for? How does it work? And what is next for this project? So first, the recruitment process. There is a side of this process that we all see. Now, the recruiter will source for people, contact them, and if they contact the recruitment team back, they will interview, and if they match, the process will continue. But there is other side that no one sees, and that is the recruiter needs to create summaries, fill forms, create showcases, and this is a really time-consuming task for the recruiter. So they have to go through the interview again, transcribe the interview, so on, so on. This represents a bottleneck in the recruitment process. So how Recruit, so what the project aims? In this first stage, generate summaries and extract relevant information from the interviews. So the team can focus in the important step of the process and gain more time to organize the workload better. So how does this work? So this is a general view of the project. The recruiter will send requests for the Recruit AI API, and the API will connect to Cohere to grab what the recruiter needs. So we can see how it works. And this is a view of the backend. We use Django REST framework to develop this API, and in here we can put the candidate name and just copy the interview and just enter the position like product owner or whatever the recruiter is looking for. We can post this interview, and the API will store this. So in other endpoint, I will refresh this real quick. Sorry. Having a little lag right now, but yeah, we can use a already saved interview that we have here, and we can select from the interview that we want the summary from, and this endpoint will provide us with a summary of this interview. So in this moment, the API is sending this interview to Cohere, and Cohere will respond with this summary of the interview. And the recruiter can grab this, put it into the showcase or the platform that uses to speed up the process. Also, there is another endpoint where that we can use to extract the tools. There's something that I implement during the hackathons to just grab what tools the candidates are using on a daily basis when working. So I go back to today. Yep. And yeah, that's how the system is working right now. It uses the Cohere backend to generate all the necessary information that the recruiter needs for the recruitment process. Here are the views that we just saw. And what's next for this project? First one, get more data that will help us to improve the prompt, so the Cohere backend can give us more accurate results. Implement a front end so we can start making a service that we can provide with this project, and support other languages, especially Spanish, for the Latin America market. Well, that's all for this presentation. And yeah, if you have any questions.
Okay, great.
Yeah, sorry for interrupting you.
No, I just want to say great. Thank you so much for the presentation. I wanted to ask, is this the first time you guys
Working
are
with
building?
AI?
Yeah, Transformers, like text Transformers.
Yeah, this is my first time I have experience with AI and working with Transformers. Yeah.
Yeah. Okay. And how did you come up with idea for this project?
Well, my girlfriend is a recruiter, so I see her and her team struggling with this step of the process every day. And sometimes it's midnight and she is still making summary for candidates or creating showcases, and it's like, this is so time consuming. There gotta be a way to speed this up. So yeah, that's the sort of the idea.
And you were you a solo team, or did you have any?
I was a solo team.
Yeah. Okay, great. And do you have any plans now moving forward with this? Are you planning to try to do something real from it, or just going, well, then there is a better way?
Yeah, I will love to, because for a personal standpoint, this is very useful for me and my girlfriend, just to have much time. But also there is a market space for this kind of projects in the staffing industry. So I want to keep doing or developing this idea.
Yeah, no, I definitely think you should do that. How I would love to know, like, how did you find it working with Transformers technology?
Yeah, well, I will say that I thought it will be more complicated than it is. Getting into a new field like AI, and you have so much information about training models and all that kind of stuff and the process. But now you have API that you can consult and just give it a prompt, and they will give you a response out of the box. That's really great. And yeah, I thought it will be very complicated, and it is not complicated at all.
yeah, it definitely opens a lot of doors. Still, I would say building something like you built require, I guess, some additional knowledge there. But the really great use cases is also when you start to mix in external data. That's when you really can create like a great products. So yeah, super cool, very well done, and it seems like you have identified a real world problem that girlfriend is up working after midnight, and you did something about it. That's very good. Alicia, do you have any questions maybe?
I do not have a question. I just want to wish you success with moving forward with your project, because the project is very good. We know a little bit about this project just because we was talking on the interview during the hackathon, and I agree completely with Matthias that like solving the real problem that you face like every day, your girlfriend face, is very important, and it's actually the main task of these hackathons. And the main mission to solve the problems using AI. So thank you so much for joining the hackathon, for joining the community. Happy to have you here. And building like very good solutions with AI. I want to invite the next team, because I see like we're moving very fast and very good. So the next team is Last Minute, and their project is AIO Medica. I'm not sure that I pronounced it correctly, but this project is about implementing AI in healthcare and like defining the cancer, right? If I'm not mistaken. I hope that Tim will tell a little bit more about this project, but idea itself is very like huge, very big, and should be very, very applicable. So could you please, you did it. Turn on the camera and great. So I'm just going to stage for you. If you're ready, you may start presenting right now.
Okay, is it showing the screen, my screen?
Yes.
Okay, thanks.
Very good.
Wait a second. Okay, on the first slide. So, thanks for the chance of presenting our project for the AI Hackathon on Transformers. We created the project IO Medica, which is an aided diagnosis tool that focuses on providing both people with self-diagnosis capabilities and clinicians with enhanced diagnosis capabilities. And we focus on the slowness and the ease of being overwhelmed of the healthcare system that has also been shown during the COVID epidemic can be easily disrupted. On the people side, we have that they do not have ways to self-diagnose quite often, and often medical checkups require quite a bit of time in advance of the booking time. While clinicians are often easily overwhelmed by the quantity of work and the tediousness of the task that they have to perform. So this often results in misdiagnosis. As has been shown also in a survey study, misdiagnoses are actually quite more common than one would expect. Indeed, more than 20% of the patients that presented to this survey had been misdiagnosed, while 66% required also changes to the initial diagnosis. So there is indeed a case for AI solutions to perform more robust diagnosis. In the case of many diseases, varying from cancer to cardiovascular diseases and so on. Often, as a matter of fact, misdiagnosis also result in death. So there is indeed a case for AI solutions to provide more robust diagnosis. And we provide solutions both on the side of people and on the side of clinicians to allow people to self-diagnose by means of the portable wearable devices, and also to allow them to receive recommendation of early checkups to detect the early onset of diseases. While on the side of clinician, we allow them to focus where it matters, where even AI tools are not able to create a proper decision. So our system, let's say, allows both sides of the healthcare system to access an API for inference and aid the diagnosis process depending on the capabilities of each of the sides. On the case of patients, we might have cell phones, they can perform self-diagnosis to the capabilities of a cell phone. While on the side of clinicians, on the side of the machinery and all the capabilities that are present in the hospital which adopts our solution. This is just an example of a demo of our product, which shows how, in the case of a digital pathology slide, in a case in which we want to detect and discern which type of cancer it is affected by, how the model determines which of the area of the image actually are relevant for the detection of the kind of cancer. In red, the areas that are more relevant, while in blue, the ones that definitely are not. The middle of the color grading instead determines the areas in which even the model is not quite sure about the kind of grade of disease that they represent. And this particular kind of slide is actually quite difficult to diagnose because it is usually 40,000 by 40,000 pixels, and the clinician has to go pixel by pixel basically to diagnose a patient. So it takes quite a bit of time. So basically the system revolves around a revenue stream based on the inference queries that are asked to our system, depending on the device and kind of system that users interact with, based on storage and also the quantity, the volume with which these are required. There is also a case for regulatory approval because medical devices often have to go through medical trials to ensure their quality and reliability, depending also on the impact that they can have on the life of a patient. The idea is to first go for the adoption roadmap, starting from on the people side, which are more eager to adopt new technologies, and it is more easily easier to allow them to try our system with smartphones, wearable devices, and so on, and then go to the small, medium-sized clinics, hospital, and so on, while earning the certification of the quality of the system. Regarding the expansion, there are many more tasks than just the one about cancer detection that I've showed. And the idea is to expand based on the possibilities that are provided also by open source platforms such as Mon AI. And this is just a few examples of how it will be expanded moving forward. So yeah, thanks for the attention, and that's all for the presentation.
Thank you. Thank you for your presentation. And if Matthias will allow me, I will start with a question. I just want to understand this model better. For me, I'm not a developer, as you may notice, so I'm more from business side. I want to know how it can be applicable, in practice. Should it be connected somehow to medical devices, or I can use it on my cell phone? How it works, in practice?
Okay, for example, let's take the case of user such as you and me, just with a smartphone. I could go, or maybe an Apple Watch. These devices allow you to monitor your heart rate, or for example, the quality of the sleep, and also other biomarkers, which are signals related to your overall health. The system will gather this data based on approval. Of course, you need the data for the models to perform. Based on this data, you could build sort of profile of the patient and determine if there are abnormalities on the patient side. Based on our models, in fact. And this is where our key competencies enter into play. Because the patient just has the data. Maybe it receives some recommendation by the Apple Watch, but it is not maybe as precise as one would obtain with an overall profile of the patient. that comes both from its clinicians and also its overall health signals coming from the smartphone, its activity, for example, does he walk a lot? Is it more of a sedentary patient? Merge all these signals and you get something that can be used for models to achieve like pinpoint accurate predictions about his health and whether it should be recommended to him to receive additional evaluation by a medical professional.
Okay, thank you. And another question I have is, I know that you have a big team, right? Do you have people in your team who are like related to healthcare? From where this idea came from?
It was just an initial early prototype that I did also in a previous project. And with the current team, we wanted to like find ways to incorporate Transformers into the idea, because in the past they were not as common or not as defined as they are now. And now Transformers are basically the building block with which you can achieve basically any of the tasks. So we wanted to explore with this current team the use of Transformers with different architectures and find ways to achieve actually possibly the best performance possible with what is now available. So with that team, it was on the side of studying what could be achieved with Transformers. In fact, we did a sort of survey review of papers of what is available now on Transformers.
Okay, thank you. Matthias, do you have maybe some questions?
Yes, definitely. Yeah, interesting stuff. I was sitting here looking meanwhile at your GitHub repo, and so it's hard sometimes. You don't know when you listen to a presentation how much is behind it and so on. But yeah, when I'm looking at the repo here, and so I see that it's probably quite some work into it, and it's quite complex. So could you explain a bit for me? So like when it comes to the end usage application, what would that be? Is it like because I haven't grasped it fully. So is it using like a visual feed, or how is the end case?
Okay, so let's say that because the case is to build a system that allows both sides of the healthcare system to interact with it. But simply, let's say you have an app on your smartphone, and you want to say, hey iPhone, let's say that I want to check if I have something wrong with my eye. How can I do that? You go in the app, you select, okay, do sort of visual analysis of my eye. That's the only thing that you can do on self-diagnosis with a smartphone, for example. So you point the smartphone to your eye and you register a short video. It was basically something similar to the thing that was doing also the previous presenter, the one of the AI talk.
Yes, exactly.
Yeah, that's one case. For example, you want to perform you don't know what you will find. That's the point, because you don't know, so you will point the smartphone to your eye and register a short video, and then the system will try to understand if there is something wrong, what is wrong. So it's sort of a hierarchical detection. You don't know, you start with hypothesis and you go forward to finding if there is actually something wrong that needs the supervision of a medical expert. But it could be also like signals from the wearables.
I want to ask, as you seem quite knowledge in this area, so like how is that transformer technology performing there? Because honestly, I will say I think most people attending most people attending and building are using like Cohere, GPT-3, or something like that. So here, this is kind of a bit on the other side of much like low level if we use computer language.
Yeah.
So please tell us a little bit more about this. I'm really genuinely interested.
You mean like the pipeline with which the model that I chosen for this demo works?
Yeah, like that. I don't know if it's like this graph transformer networks.
Yeah. Okay, so basically it is a two-step process. You take the slide, the pathology slide. Basically, this is a slice of a tissue from a pulmonary, taken from the lungs of a patient. Then with this slide, which is a very high resolution, you extract some convolutional feature from it. With these features, you build a graph for which you like create a grid from the original slide. Is it like, do you hear the noise in the background? Or is it like...
It's your washing machine, I think.
Yeah, it's take off.
But it is how it is. No worries.
Okay. So anyway, basically you take this slide, you slice it into a grid of like larger pixels. For example, you take this and you slice it into greater areas. As you can see, there are like areas that represent some zone of the image. And these areas basically go about building a graph for which you have the features of each of those blocks. You build a graph from this, and the graph is used as an input of the graph transformer, which is used to like detect how the connections between different zones of the image interact with themselves. And based on the graph structure that you extract this way, you find some like local but as well global view of the slide that is used to predict the type of cancer. It's a bit convoluted, but like essentially it's a two-step process. You first extract some feature from the image and build a graph from them, and the graph allows to find like a more fine-grained representation of what is the sample that you're looking for.
Mm-hmm.
Because
Yeah,
with a traditional convolutional network, you just see the local patches, or even larger areas if you take large convolutional filters, but not how they relate in the global context. And that can be done with transformers.
Mm-hmm. Yeah, that's super interesting. Actually, I'm super amazed. I mean, after this, I need to just go and dig a bit deeper in this corner of Transformers because I learned some new stuff now. Okay, that's super exciting. So I want to ask you had a fairly large team. Did you guys know each other since before, or you came together met at a hackathon?
We came together in the channel, like as the team name mentions at the last minute. But like of course some people were not on the like not in the field, so there was need for more guidance. Like we were not on the same page at the beginning.
Mm-hmm. So and how did you find it to work with this different people and coming from different level of knowledge in the AI field, so to speak?
It is like difficult because some maybe do not have actually the knowledge. Some instead do, and like can help quite a lot in speeding up, for example, the literature review. That also for example, the guest of the AI talk mentioned that it took 1 year, for example, to complete the review of all the papers.
Yeah.
But the knowledge from other people can be used also to skim through the papers, and that's one of the most relevant parts.
Yeah, but I'm sure they were happy to have you and your expertise in the team, though, the other ones.
Hopefully.
Okay, thank you so much.
Thanks for
Great,
you.
great thing. It's a little hard to like get it all, and it's very technical thing also. But I really like it. What is your plans going forward? Like, are you working seriously with this, or is there plans to do that, or is it just like some research?
I would like to do the part that I mentioned, here, because that's quite achievable, and you can do it also on a mobile app. I developed some app in the past, about currency converter, things like that on Android. So some things like that can be done, and I would like to at least do this, which is achievable also in the sense of a roadmap, and allows also to gather possibly users.
Definitely. And yeah, regardless how it goes today, we are always here to help or support, to give you some guidance if you need anything moving forward with this solution.
Yeah, thanks a
I
lot
guess
for
that
that.
I guess that is all questions I have on my side. Olesha, do you have anything more, or do we move on to our last and third?
Yes, exactly. We're moving on to the next team. Thank you so much for your presentation, for joining the community. Yes, and the next team, I'm sure that I will pronounce it incorrectly, but it's Hummingbirds. And they excuse me?
Just disconnect like that, or they move me out of the channel.
You may just leave the channel. That's
Okay,
it.
thanks. Bye.
Yes. Bye-bye. Thank you. Yes, Hummingbirds was the project which is research paper clustering. And this project is like a blessing for all people who are working with university papers, with researchers, because it helps you to find the field of studies and other researches related to yours. Guys now will tell us more about this project. And I guess it's really amazing because we also had a very nice talk during the hackathon. So if the team is ready, just let me know that you're ready.
We're ready.
Great. Happy to see you.
Oh, sorry. Yes, turn on my camera.
Great. I see the stream. So if you are ready to start, I'm leaving the stage for you.
Okay, perfect. Thank you.
Great.
Hi. So we are Rahel and Sasha. We're two brothers. We're both software engineers and data scientists based in Canada. And we're really excited to share our project with you. It's semantic search and clustering of research papers. So researchers generally find new papers by looking at related research sections and references in papers. The problem with this is that it could easily lead to getting stuck in sort of a local cluster of research. And one of the other things too is that researchers might be trying to solve a difficult problem with novel research, but it might be hard to find applicable concepts if the concept doesn't exist in that field yet. So our goal is to help researchers and students find relevant research using semantic search and sort of a clustering approach. So this will hopefully also help find research concepts that are used in other fields but haven't been applied in this one, but might be applicable in this one. So our approach is as follows. We connected to Archive, the open source research paper repository, and we extracted some information just for the purposes of this project. For each of the papers, we extracted the summary, the title, the subject, and the link of the papers. And then what we did was we used Cohere's transformer model to embed the summary of each paper into an n-dimensional vector. And then we used Annoy to basically put these into an index. And then when we get a query, we find the closest n papers to that query using Annoy. And then in order to sort of plot them and make it easier for us to understand, we actually used UMap to plot them onto a 2D space. And now comes the interesting part, is where we generate hierarchical clustering of the papers. And what we do is then we calculate the frequencies per each of these hierarchical clusters. And we do that in order to identify the concepts that are present in the cluster. And we think this is sort of the most valuable thing, because it provides the user with an understanding of sort of the concepts that connect all of these papers together. And then we sort of built an interactive UI in Streamlit to allow the user to interact with the different cluster levels, change the input query, and then also be able to connect directly to the papers from the interface. And now Rahel will give a demo of our working project. Yeah.
Yeah, so here we have a chart where each point is basically a research paper. And so for our proof of concept, we downloaded only 500 papers, but in the future we'd like to download more. But essentially here we can see the clustering algorithm at work. When we download the papers, we also download the subjects, so we know we get an idea of where the papers are being clustered. So here you can see the clustering algorithm at work. You can see here on the right side, we have economics papers. And then this clustered, like these papers are all sort of close together because they're related to mathematics. So mathematics, statistics, quantitative bio, and then astrophysics is up here. The user, we can enter a query. So for example, if we enter high energy black holes, it runs the program, like gets all the embeddings, queries, Cohere's API, and essentially it puts your query in next to some papers, so you can see what papers are related to it. So here we see high energy black holes is mapped close to astrophysics and math papers. In addition, we can change the number of papers that we want to see that are closest to it. So before I had put 500, but now I put 100. And the points are clustered to different levels. And you can adjust the cluster level by adjusting the slider. So if you want to see two clusters, then you can put this slider down by 1. So now we see two clusters, and it clusters it according to what's closest in that cluster. So here we have a mathematics cluster and an astrophysics cluster. Then we can show 3 clusters. So we can divide it up further. And we can keep going all the way until each paper is its own cluster. So here you can see that our query, high energy black holes, it's within this cluster of astrophysics. Obviously, we can fine tune those clusters some more and get a more compact cluster view. And so the keywords of this cluster is astrophysical jets and experimenting on them. And so in addition to that, you can also click on a point. So let's say, so this paper is the closest to our query, so we can click on it and we can see the title as well as the summary of that paper. And in addition to that, the cluster slider also changes so that whenever we increase the slider by 1, it will show new papers that are added to that cluster. So this way, a researcher can see what papers are actually closest to that. So here, the paper that was connected to it was this one, jets relativistic and non in astrophysics. So a user might say, okay, yeah, that's the one that's actually most related to it. And we can add some more papers to that cluster by going even further. So here, this one got added to that cluster. And then you can deselect the paper just by clicking clear selected. So now we'll talk about future work. So for future work, we'd like to train a custom large language model. And that way we can improve the accuracy of where the research papers are actually placed. We'd also like to interpret the attention mechanism of the model. And this way, instead of doing frequency analysis of words, we can actually look at where the attention is focused off the transformer model to identify specific keywords or concepts, and that would be much more accurate. And finally, we'd like to just improve the user interface. And one example is to allow the users to track changes in clusters between steps, because as you saw before, it was hard to see how the clusters were changing. So yeah, that would be future work. And now Sasha will talk about the business cases.
Yeah, sure. Archive is a repository of research papers, and we're sort of pulling our data from them. So we just want to say thank you to Archive for use of its open access interoperability. So in terms of future work, ideally we can partner with things like Archive or other publication platforms as sort of a paid service. However, this project is research paper agnostic, so it can sort of function with any data set. Alternatively, I'm sure there are many researchers at universities or students, as well as research labs that could use this tool in sort of an open source manner. So we could provide the code, and then they could, put in their own research papers. So we have sort of a two level options. That's sort of what we were thinking. And we just want to say thank you to LabLab AI for hosting this hackathon, and we look forward to doing it again. Thank you.
Thank you.
Thank you so much for your presentation. Do you want to be first, Matthias, with the question?
Sure. Hi.
Hi.
Great to listen to the presentation, and I really like the application. I want to start with asking, did you form the team at the hackathon, or you know each other since before?
Oh.
I've known him since I was born.
We're brothers.
Okay.
Yeah.
That's cool. And so this the thing you built, had you been thinking about it before, or was it something you came up with during the event?
About a week before the hack, well, we signed up for the hackathon, and then about 4 days before the hackathon, I think I just had the idea of like seeing research papers mapped onto charts, and I was thinking, oh, we could do semantic search of research papers. I don't think there was necessarily a specific case that prompted me to to have that idea. I just thought it might be interesting to do and to see whether we could actually cluster them using Cohere's language model.
Yeah, and I also think that, I have done a little bit of sort of research paper studying as well before, and I have always found it interesting the fact that there are other concepts from other places that can be applied and brought to your field. Like, I find that concept really interesting, and you just might not think about that because you're so like focused in your own field. So like building this tool, hopefully we can allow that to happen. So that I think that's a really interesting, yeah.
Yeah, definitely. Does it currently it allows for clustering? Did you implement anything yet that actually say you can retrieve some specific information or ask some questions or so at the current step?
Not any sort of questions. I think it more sort of does just maps the query into a vector and then puts it on the space. So I don't know if you could ask a particular. I mean, I guess you could ask a question, but I don't know how well that would work. Yeah, that would be something we'd have to sort of test.
Yeah, it's not formatted as sort of a text generation way, so like it can't. You can ask a question, but it'll just be looking at the semantics of the paper and matching the semantics
to the summaries. Yeah. So as opposed to generating based off of those papers. Yeah.
I think you have a great base in what you have built, and you have probably a couple of interesting paths to move forward to give some extended capabilities. There is a lot of, with this technology, so much cool stuff that can be done. Just for example, like understanding, classifying the stuff, like how positive is the author maybe for this, and you could see over a timeline if positive, like the belief in something or result keep increasing or something.
Yeah, and there was another idea as well, which my friend actually mentioned, which was identifying gaps in research as well. So you can see two research papers that are connected, maybe, but you realize that you can put something in between that's actually going to connect them even better. That has both concepts together. So that was actually another area that I was like, we didn't, that's another thing that you can add sort of as well.
Yeah, another part to that is, so we used Annoy indexing, but there is another indexing tool called Pinecone, where you can incorporate metadata into how it maps the vectors. So basically, that metadata could also be used as clustering. So you could see more recent, for example, date that it was published could be
more recent research, and then maybe citations and things like that as well.
Yeah.
Right.
Yeah, definitely, and there is we basically work with most of kind of leading labs in this space, and you also have so they all have a bit of different functionalities and capabilities. So I think it could be a wise thing to also look into basically what, say, AI21 or more specifically OpenAI have some really good functionalities when it comes to searching through a lot of data and extract basically whatever you want with it. But it's different building blocks. So I see like what is really cool is when people start to kind of stack these different transformer technologies, because they can really feel like so big blocks in your development cycles. It's really nice.
Yeah, exactly.
It's
so one. Yeah, I'm sorry.
Sorry. Oh, I was gonna say that like I feel like in some ways it's restricting, whereas in other ways it's very advantageous. Like restricting in the way that, for example, we wanted to see the attention, like where the attention was from the transformer to identify keywords, but we didn't have access to the model because it's access through an API. So, but in that way, it makes it very easy to use for a specific use case, but makes it
like it was one line of code to get the embeddings, which is like really nice.
Yeah. I often tell people that like take off the shelf, like the best stuff around. Build on that first, like make your concept, see if it works, and from there decide if you want to spend the time and the money to train your own model, which is very hard to even get to the same level.
Exactly.
As a last thing, I've or two fast questions. So first one is like, what is your guys' background? Do you have any programming experience and so on? I get a feeling you might have. And second is just, are you planning to do anything more with this, or was it like a fun project?
I can go. Yeah, I have sort of a background in AI research and software engineering. So I've been doing that for the last 5 years or so. So this is just sort of a very fun project. Rahel?
Yeah, I also have just a background in software engineering. I'm getting into data science and machine learning. And yeah, I saw these hackathons. It would be a good source of motivation to finish a project within a timeline.
Yeah. And sorry, go for it. Oh, no, I was just gonna say, in terms of, I think we're definitely planning on continuing the project, even if it's not in any kind of commercial way. I think at least in an open source way. I will sort of build it up, and then if it gets to a point where it's a lot more polished, maybe then we can look at sort of commercial applications.
Mhm. Awesome. Alicia, you have
Yes.
any questions?
Yeah, I wanted to ask you, probably not, but is it your first time working with transforming technology, especially like GPT-3 and Cohere, this technology?
Yes, actually, yeah.
Yeah.
Yeah. Particularly Transformers. Yeah, not standard neural networks. Like I'm pretty familiar with sort of feed-forward convolutions and convolutional neural networks and stuff like that. But particularly Transformers and Cohere as well. It's the first time. Yeah.
I'm impressed because you mentioned that you have like quite big experience in working with AI and working with software engineering. So, and how
Yeah.
do you feel working with these technologies? Especially like, what do you think about the applicability of transformers for different like fields, for different
Oh,
projects?
it's really cool. It's honestly really cool. Very excited for the possibilities, and I just like the fact that it can you can use the same model to use it on different types of data sets. Like you can use it on images, on tabular data. You can use it on NLP. Like just the use cases are so, and you can have all that stuff just combined into one thing and pass it into a model. Yeah, it's very cool. It's very cool.
Yeah, and is it your also first time on LabLab as a platform?
Yes.
Okay,
Yeah.
that's great. Okay, I do not have more questions. My main question when I was listening to you, and how did you come up with the idea? But you just mentioned, so I thought it's also like from your university experience, probably, and working with
Yeah.
AI. Yes. Yeah.
Yeah. And you just hear a lot of stories of people suddenly, like, especially in like math fields, they're working on trying to solve a problem, and then suddenly somebody mentions something from a different field, and they say, "Oh, wait, I can apply that here." And I think that was true when they solved Fermat's last year. I'm not sure if you're familiar, but it was a similar thing. They pulled in a concept from somewhere else. So yeah, interesting.
That's amazing. I want just to say thank you for being with us. Thank you for joining the LabLab community, and yeah, and happy to have you in top 3 teams here. So, guys, I want to ask you for a 5 minutes break to Matthias and to the team to check out all the projects again and to come up with winners. And
Okay.
in 5 minutes, we'll come back and we'll announce who will be the winner of Transformers AI Hackathon. So
Perfect.
thank you so much. We'll be back shortly.
Guys.
Hello, everybody! Once again, we are happy to see you here on Winner Announcement Stream. And after a short break, we are ready to announce the winners. But first of all, I want to say a huge thanks for DigitalOcean for being partners with us on this event and for providing credits for winners, because winning team today and the top 3 teams will receive credits from DigitalOcean. Okay, I don't want to wait for a long time. Can we just start with announcement, Matthias? Or you want to say a couple of words before?
I think like all of your projects was really good actually. So it's really hard actually to choose a winner because all of you did. I'm always like surprised when we have this like how good stuff people actually are doing, and I think like in this case like all 3 of you have done like very different things, but all really good and with really big potential and also market value. So like regardless, I want to say also like regardless who wins, we are more than happy to see how we can help every one of you to move forward. So Anastasia will share some meeting link with you later, and you can set up a call, and we are more than happy to jump in and talk and see if there is anything we can do to help you move forward with the project.
Yes, and before announcing the winners, I also will tell about prizes. So everybody from top 3 teams will receive credits from DigitalOcean, as I mentioned. And also, yes, you're able to book a meeting with Matthias and Pavel, which is our founders. And we are happy to provide you further support of your projects to help you to find the right direction to develop your project in the future. So you will have the support. So that's why really congrats with being top 3 with your hard work on the projects during the hackathon. Okay, so to don't bother you, the winning team of this hackathon, will be Hummingbird. So
what? Oh wow!
But really, great job, everyone. All of you are doing super cool stuff. And please book a call with us. We are more than happy to see how we can help out. And I'm sure we are giving some credits to the other 2 teams also. I guess we will sort it out. Everyone gets credits. Number 1, of course, get a bit of extra credits. But yeah, really cool. And I don't know, maybe it's time we have two brothers in a solo team. So yeah. So
yeah,
thank you so
very
much. Everyone. Yeah, Olesha.
Yes, I didn't finish with 2nd and 3rd place. So for us, it was extremely hard to choose these places because you have completely different project and all of them is very cool. So what we decided is to not choose like the last team. We will put both of the teams. So it's Reclu AI and Last Minute on the 2nd place. So you will receive for sure the same amount of credits, but what the most important, so you will receive the same support from the team of LabLab. So we are super happy to have you here. And huge thanks for building your project with AI and for changing the future and basically with this technology. Yes, so the first team is Hummingbirds, and the 2nd place is Reclu AI in Last Minutes. Just to summarize, thank you so much, guys. If you have some words to say, this is your time.
I think
it was such a great hackathon.
Yeah, it was really fun.
Yeah, great that you like it, and we are. Please come back again, and if any one of you want to engage us, mentor, anything like that, you are more than welcome to. And I guess we will create some specific Discord status for teams that make the top there, and also somehow mark it out on the lab platform. But yeah, thank you so much for coming. Like for us, it's all about we just see how this technology is changing the world, and we just want people to come and build on it, and then maybe you go and create a really big companies, and you will remember this this group of people and what we are doing, and come and talk with us then. So yeah, big congratulations, and please, if anyone have anything to say, go ahead.
If I can, I would have also chosen that one.
You're too
really
kind.
good, like, no, really.
Thank you, I appreciate it.
Okay.
If nobody have what to say, yes, I have what to say. So guys, don't forget, for everybody who's watching the stream and for everybody here, don't forget this like next weekend we'll have next Stable Diffusion Hackathon. So you're more than welcome to join us to build this like amazing image, like text to image technology. So image generator, just come and build with us. And the registration is available on lablab.da website, so you can just go and sign up, enroll, and we are waiting for you there. Thank you again for all teams, for all more than 1,000 of participants. And yeah, see you in a week. See you in a week.
Yeah, big congratulations to everyone.
Yes.
Thanks. Bye.
Bye.
Bye-bye.
Yes.